Now we're going to verify this trig identity. They want us to show that this expression is equal to this expression. So again, we set it up and we create equal signs until we get all the way down to the other one. Don't work over the equal sign. So one of the tricks to these problems, it looks so simple. In fact, some people would like to start with this side, which isn't a bad strategy, instead of starting with the left side. It doesn't matter which side you start with, as long as you don't work on both sides of the equation. Start with one side and work until you get to the other side. I'm going to start with the left side though, because usually that's how they want you to do it. So what I'm going to do is I'm going to multiply this by 1 plus sine r on the top and bottom, because that's the conjugate of that denominator. So when I multiply 1 minus sine r times 1 plus sine r, I get, let me clean this up here, and sometimes you don't know exactly how much room you need for the equal sign. When I do that, I will get 1 minus sine squared r, and on the top I still have 1 plus sine r. This down here, if you remember your trig identities, is just equal to cosine squared. So I have 1 plus sine r over cosine squared r. And now this right here is, I can distribute the cosine into both terms, the cosine squared. So I have 1 over cosine squared r plus sine r over cosine squared r. Looks like I might need one more line here, so I'll just write it right here, which equals, well, it really just equals this if you can see it. But I'm going to split this up now into, so this is 1 over cosine squared r, which is just secant r, plus sine over cosine r times 1 over cosine r. I split this up into sine times 1 over cosine r times cosine r. And I just split it like that, essentially, which gives you the bottom, and you're done.